Hello everyone, welcome to this new webinar organized by SVI. Today I would like to tell you more about the latest release of the Huygens Remote Manager HRM 3.7. And in order to do so, I'm going to use this demo installation which we have made available at hrm.svi.nl. And I would like to encourage you to feel free to use it for testing purposes. And if you have your own production HRM that's offered by your imaging facility, I can imagine that maybe using your own production machine is best for most situations. But if you want to test on this installation, you're more than welcome to do so. So I will open a browser and point it to this address, hrm.svi.nl. And as I said, if you want to use it for testing purposes, just sign up here. And for the rest of the presentation, I will log in with my credentials and show you what you can do with this latest version. So unlike in the previous version 3.6, where we introduced many user interface changes, in this 3.7 version we've concentrated on performance issues and stability improvements, and also a few small features that, even though they're small, I think can make your image processing a lot easier. So let me show you all these changes, and first let me get started by telling you about the home panel, which did not change. So still you can upload your data and download your data and have a look at your statistics, manage your jobs in the queue, change your account, and of course launch jobs, which is what we are going to concentrate on today. So if you go to the launch jobs, you'll notice that all images are now listed by default. So it's no longer necessary to first make a choice of a file format in order to proceed. One can still definitely do that for ease of usage, but it is now possible to see all files at once and also to launch a batch of files of different formats. So if you still find it useful to filter a specific format, that's okay, you can use it. But for the ease of usage, we thought that enabling people to mix different file formats into the single batch could potentially be helpful. So in order to illustrate that, I have 100 wide-field images here, all of them recorded with the same settings and saved as HDF5s. Then I have an extra wide-field image, also with the same settings, but then saved as ICS. And as you can see, we can now just simply select everything and add it to the selection, and that will be fine. HRM will be able to handle that, which previously wasn't possible. You probably noticed that this small step works now a lot faster than it used to. So I hope that the whole selection of images, the improvements that we brought there help you in using HRM. So if you continue to the next stage, then you need to set up the microscopic parameters for restoring these images. And it turns out that I don't have any templates, any suitable templates for these images in my own template area. The HRM administrator did not provide with a template for this wide field microscope either, and the sharing area doesn't show any templates from colleagues either. So I will have to create a new one, and the easiest way to do that now is by clicking on From Image, which means you will read the metadata of an image and turn it into an HRM template. So simply select an image from the batch and accept, and HRM will show you the contents of the metadata in the form of an HRM template. So what we see here is that the images contain 4 channels, and if you try to continue to the next step now, you'll get a warning that you have to make a decision between using a theoretical PSF or a measured PSF. So I'll go for theoretical and then continue to the next page. And you see here that all the metadata from the images has been loaded into this HRM template. So the images have been recorded with a wide field microscope and were recorded with this lens of this numerical aperture, these wavelengths, and the refractive indexes, which also feature some mismatch. This, by the way, will ensure that the images have some spherical aberration, which we can correct by setting that up in the deconvolution in HRM. I will show you how to do that in a second. So if we now continue to the next stage, we see that also the sampling sizes have been loaded from the metadata, and that they are even compliant with the Nyquist criterion, which is highlighted there. So we are good to go. If we continue to the next stage, then we have this last page on configuring the spherical aberration correction. And the first question is probably the most important in this page, which is plane zero of the images closest or farthest from the cover slip? And the reason we have to ask this question is because we need to know about the orientation of the image, if it's upwards or downwards. And a way to help you provide us with this information is by clicking on this visualize image. Then you can select an image from the batch, and if there's no preview from the image, you can generate it here on the fly. And then you see that there's this XZ view, of course also the XY view. The XZ view shows that the cover slip is probably here at the bottom of the image, right? So this being plane zero and the cover slip being there, we are now more sure that if we go back and select plane zero is closest to the cover slip, that should be fine. So we will accept the microscopic parameters. As always in HRM, when you select a template, the contents are displayed on this preview, so you can make sure that everything is correct. And now we can continue to step 3. So here we will configure the restoration parameters. And there's a 4-channel template for wide field data from a previous batch that is suitable for this batch as well. So in this case, I don't need to create a new template. However, I would like to show you some of the new features that we have added to the restoration templates. So I'll select the template and click on Edit in order to change some of the contents. Now, one of the new features in this version is that you can now select different deconvolution algorithm for every channel. So you can choose between CMLE, QMLE, GMLE, but you can also select to skip a specific channel. And in fact, you can even skip all channels if you want to. So this in fact turns HRM into a batch file converter or chromatic aberration corrector or time stabilizer or colocalization analyzer, right? So you don't always have to do deconvolution on your images. You probably already did on a number of images and now you want to do colocalization on them. Okay, that's fine. You can process that on HRM. You can just skip deconvolution and concentrate on colocalization. So for the rest of the example, I will go back to the previous selection, the CMLE algorithm, because these images are in fact raw, they are wide field, they need deconvolution. I will switch to this same deconvolution algorithm for all channels. You might wonder when you also want to mix channels for the same dataset, mix algorithms for the different channels of the same dataset. And that is mostly when you have very challenging situations, challenging images. For example, when you're mixing confocal channels and step channels, then you might want to proceed to process the step channels with GMLE and the confocal channels with CMLE. But in most cases, I guess sticking to the same deconvolution algorithm for all channels should be fine. So if you now continue to the next stage, you'll see that we've also measured the chromatic aberration introduced by the optics of the microscope, and we've measured that by using multi-channel beads and also using the chromatic aberration corrector in either Huygens Professional or Huygens Essential. And we know that by applying these shift vectors back, the chromatic aberration will be corrected. So we will want to do that on all our wide field images from this batch. As for the stabilization of time series, I will leave that off because these images don't contain any time lapses. Okay, so then we are now good to go and accept the changes, go back to the restoration template selection. And once again, if we select the template, we see the contents on the right hand side, including the chromatic aberration vectors and the different deconvolution algorithms for each channel. Perfect. So let's now continue to the next step where we can select the type of analysis that we want to do, the type of colocalization analysis that we want to do, and I'll go for all coefficients, all colocalization coefficients for all channels in these images. So one last step, step 5, here we've got the summary of all the parameters that we are going to send the batch of images to the server with. You can also select the different output file formats. And lastly, we've worked hard to improve the performance of this action, finally sending the images to the server. This used to be much more time consuming, and now, as you will see, this has become really fast. So we've just added 101 jobs to the queue, and if we now go to the queue and have a look at the speed, at the status, we see that HRM is already processing the first job, the first image of the queue, and here on the server column you see the name of the server processing the image. So this is actually a different server. It's not the machine where this web service is executed, but it's a different machine. It's a machine that is of course connected to the web server, but it's a different one. And the number next to the name also indicates the GPU ID, so the identifier of the graphic card where the processing is being done. And this is also good to remember that by adding new GPU cards to your server, if you have any GPU card laying around, you can just add it to the server, and this is a way to increase the parallelization of the HRM queue, okay? Because in that case, you will be able to process as many jobs in parallel as there are cards. Now let's say that you also made a mistake in launching a specific batch of images and that you want to remove them from the queue. You can simply just make the selection of images. In this case, I will just select them all and click on, once again, I'll select them all and click on delete. And this used to be an action, a little bit of a shaky action in previous versions of HRM. It used to be a little bit unstable here. We've also worked hard to improve this part. You will see that HRM recovers now in a few seconds, and that is again waiting and listening to process new jobs. So this has become also a little more robust, and we are happy to ensure that the whole of it is working more robustly. So lastly, let me quickly show you the results page. This did not change in the last version, but I think it's worth looking at because of its inherent value. So I'll go back to the home panel and then to results, and just simply select one of the images and click on detail view. And here again, we have the comparison between the raw data and the deconvolved data. You know, the MIP for XZ, for XY. We also have the simulated fluorescence process, raw data versus deconvolved data. We have parameter tables with summaries of all the values used for deconvolution. We have the colocalization with the two-dimensional histograms, of course, the coefficients and the colocalization maps. All of it has been processed by the remote server. So HRM, the central, the web server, has retrieved everything from the remote server and is showing that to us now in the browser. So I think this is a nice page to show you how you can first assess the results of the deconvolution, and whenever you're interested in doing more analysis, then you can download the data to your local computer to do further analysis or visualization and so on, right? So I think that this is mostly what we had time for today. I think we probably have still a little bit of time to talk about OMERO, because some of you are really interested into communicating HRM with an OMERO server. And in order to quickly show you how that works, I will go back to the home panel, and then in both folders, the raw images and the results, we show OMERO buttons that allow you to either import or export data from and to OMERO servers to HRM. So of course, your HRM administrator first has to set that up so that HRM talks to the right OMERO server, to the correct OMERO server. Simply, if you want to pull data, if you want to import data from OMERO, simply click on the button and fill out your credentials, type in your credentials, and HRM will talk to the OMERO server, will pull all the information about the projects that you are entitled to import, and then whenever you want to import images, simply make a selection and click on the import button. Then it will take a few seconds, and the images will show up in your raw images folder. So here, notice that the thumbnails are smaller than in the traditional HRM previews. That's simply because HRM pulls the thumbnail from OMERO. If you want to go back to the traditional HRM previews, simply click on recreate, and then you can now proceed to the deconvolution of the images imported from OMERO. And the same applies to the export of your deconvolved images to the OMERO server, right? Only you have to do that from the results folder. So I think this is really what I wanted to show you today within the limited time that we had. So I hope you enjoyed it and that you find HRM 3.7 even more suitable for your imaging needs. That's all. Thank you. Have a nice day. Bye.